Welcome all of you to Animaths. In today's video, we shall be continuing with square roots. Okay, squares and square roots. As we know, this is our fourth part of square roots, and in this part, we are going to take up the decimal numbers, finding square roots of decimal numbers with the help of division method. Okay, in the last video we had done the division method. In this video we are going to take up decimal numbers only. Okay, last video we had taken whole numbers. Now apart from this, we are going to take up few types of very typical type of problem sums where we'll have to use the division method mostly. In sometimes you might have to use both the methods. Okay, so the problem sums that we are going to take up is sometimes you find them very difficult, like what is the smallest number, the smallest 4-digit number which is a perfect square, or the largest 3-digit number which is a perfect square. Find the largest 3-digit number which is a perfect square. So things like that. Okay, let's see what else. We have few more interesting questions and very important questions. Okay, I always pick up the very important types of questions. So if you go through the entire video, you'll be able to get all the important types of questions of this chapter. Okay, so let us now start with the sums then. Let's take the number 71.4025. Okay, so 71.4025, we have to find the square root of this number. Then we can already see that this is this is a decimal number. So this side will make a pair like this, and the other side, okay, we pair it like this. Now remember, if we are pairing the decimal number, for the whole number part we pair from the right to the left. For the decimal part we start pairing from the decimal point and go towards the right. Okay, so if there is any digit here, supposing there is one more 3 here and it's not getting a pair, so we can easily put a 0 after that and make a pair out of it. That is the reason. Okay, so now we'll start with 8 into 8, 64, and then this is a 7. Put the point, bring down the full 40, full set has to come down, full pair. Double this 16, and then here what do you write? Okay, so that it goes very close to this. Now if I take 16 into 5 is 80. Okay, 16 into 5 is 80. So it won't work. Then shall we try 4? 6 4 is 16, 1, 6. Looks like this should work. 6, 56, 4 and 1. This is a 6. So 8. And here we shall write a 4 then. That means 164 we multiplied with a 4. And once we have written a 4 here, we should also copy down the 4 up here. Okay. Now we have 84. The next batch that we are going to, the next pair is this. Okay. So now here we are going to double this and not this. Okay. So 88.4. You don't have to consider the point at all. Don't write a decimal number over here. This is the place only to write a whole number. So do not write a decimal number simply because you have doubled it. So here it is going to be how much? 168, right? 168 and then a gap. Now we have to write a digit here. So if I write, let's take 2, it is going till 32. Okay. So this is how you have to estimate. So how far? 16 5s is 80. Okay, so that is why this is very close to 80. So let me check with 5. Okay, 25 and 2. This is 42, 4, 30, 34, 8, 4. So this is how we get it. 8, 4, 2, 5. We got it exact. This was the sum was such that it won't leave any remainder. So here we are going to put the 5 and put the 5 here. So my answer to this one is a 8.45. That is the square root. This is my answer. This is the square root of the given number. Okay. Now we shall be taking up another question in decimals only. So let's see how we can do that sum. This is 25.6036. This is my number. Okay, 25.6036. How can we find the square root of this? Let's start pairing first. Do not forget to pair. You have to pair. Okay, and if sometimes we forget to pair and the sum goes wrong easily. 5 and a 5, 25. Put the point, bring down the 60. Here it is double this, which is a 10, and what to write here. Now when we put a 10, it has already become double digit. Here we have a double digit number. So even if we put a 1 here, it will go beyond this. That means this pair is not working. Okay, this is not enough. So what to do next? We have to bring down this 36 also. Okay, now since this 60 didn't work, we are going to put a 0 here. Okay, you can take it like that. So here now 6036, I think if we put a 0 and then if we put a 6, okay, 1006 into 6, this is 360 and 1. See, and 6. Okay, 6036, that is the correct number. So we put a 6 here. Since we have already put the 0 here for this set which didn't work, we can only put a 6 here. Okay, so my answer to the question is 5.06. that is my square root of this sum. Okay, square root of 25.6036 is 5.06. Okay, now we shall be taking up few more questions where you will see that we had done what must be added to or what must be subtracted from types. This is going to be almost like that, very close to that. Okay, so these are few problem sums. As you can read in the question, the question is saying find the greatest 3-digit number which is a perfect square. Okay, I'll write it here too, greatest 3-digit. It's there given in the question also, as you can see, digit number which is a perfect square. Okay, so we are trying to find the greatest 3-digit number. It is not enough if it is just a 3-digit number. It has to be that 3-digit number which is the biggest one, which is a perfect square. The biggest 3-digit number which can be a perfect square. Okay, like the biggest 2-digit number which is a perfect square is 81. Isn't it? Because 9 into 9, 81. After that, if we do 10 into 10, it becomes 100. So we reach a 3-digit number. So 81, that is the greatest 2-digit number. Similarly, we are now going to try and find out the greatest 3-digit number, which is a perfect square. Now, if you see here, this is 100. Here, this is where our 3-digit numbers start. And where does it end? It ends here, 99. Okay. So the greatest 3-digit number is 999. Okay, that is my greatest 3-digit number. In that case, if it is so, 999, then now if we are going to find the greatest 3-digit number, remember it will be somewhere below 999. Now we don't know exactly where. Okay, we don't know exactly. Will it be 998? Will it be 800 something? Or will it be 901? But it is definitely going to be less than this because they are asking for the greatest 3-digit number which is a perfect square. Now let us do one thing. Let us find the square root of 999. Okay, by division method. This is 3, 3. Now you already know this, and bring the 99 down. Here, double this 6. What can I write here? Okay, so I can write here at most of 1. If I write even 2, it will become 120. It will go more than 99, isn't it? So I am writing a 1 here. 61, that's an 8 and a 3. Okay, so the remainder is 38. Now you have to understand one thing. 31 square is 38 less than this, isn't it? 31 square is 38 less than this. Okay, that means the greatest 3-digit number, but it is also a perfect square, is actually 38 less than this number, that is 31 square. Because after that, if we do 32 square, we can also check it. 32 into 32, say 4, 6, and then this is 6 and 9 and 4 and 12, and see it has crossed, okay, as you can see it has crossed the it has crossed 3-digit numbers, okay. So we have to stay within 3-digit numbers, and hence the greatest 3-digit number which is a perfect square is 999 minus 38. Basically we are trying to find 31 square, okay. So that is 1 and 6 and 9, which is our, so 31 square is actually a 961, and see we are lying within the correct range. So the greatest 3-digit number which is a perfect square is 961. We found it. This is nothing but an application of what is the greatest, what must be added to type, or what, this is actually what must be subtracted from to make it a perfect square. It is that type of sum, okay. If you have noted in the previous video we had what must be subtracted from, this is exactly that type. It's an application of that, okay. Let's take up another sum which is quite similar to this, which is what must be, what is the smallest 4-digit number, smallest, as you can see written in the question, 4-digit number which is a perfect square, smallest 4-digit number. Now here 4-digit numbers start from 1000, isn't it, and go till, okay, 9999. This is the greatest 4-digit number, this is the smallest 4-digit number. In that case the smallest 4-digit number will lie somewhere very close to this, okay. We'll try and get it as close to this, but then it has to be a perfect square, it has to be a perfect square. Now what to do? So we shall be doing the square root of this, okay. So if we do the square root of 1000, pair it 3, 3, 9 and 1 and 100, make it a 6 and 1, okay. 61, this is a 9 and this is 3, here you put the 1, okay. So you get a remainder of 39. That is, when we found the square root of this, the 31 square could only be the, we can get it as 31 square. After that there is a remainder, that is, if we subtract 39 from this, we will be getting a, if we subtract 39, in that case we shall be getting a, if we subtract 39, then we shall be getting a perfect square, that is a perfect square of 31, okay. But then that is not what they are asking. They aren't asking that. What are they asking? They are asking what is the smallest 4-digit number which is a perfect square. That means if 31 square lies here, okay, we already saw in the last question which is a 961, okay, then 32 square, that is the very next square only, will lie above 1000, and that will be the smallest perfect square, because 31 square here and 32 square above this, isn't it? So 32 square is actually my answer. So let me do 32 square, 32 into 32, that is 4 and 6, and this is 96, sorry, 96, 4, 12, 1024. So 1024 is 36 square. So what is the smallest 4-digit number? The smallest 4-digit number which is a perfect square is this. So this is your answer. Please don't write 24 has to be added to this in order to make it a perfect square. That is, they are not asking what has to be added. They are asking what 1024 is, what is the biggest, smallest 4-digit number which is a perfect square. So the smallest 4-digit number, by doing 32 square, find the answer. So what did we do the square root for? We did the square root for only to get the value 31, so that we can know the value 32. Okay, so that is it. So again you see, this type of question is of the type what must be added to make it a perfect square, isn't it? In the last video I had done that type of questions. Okay, so this was again another very commonly asked type of question in the square roots chapter. Now let me take up another question which is quite interesting. See, these are the, these come under problem sums of squares and square roots. Find the smallest perfect square. The question says find the smallest perfect square which is divisible by 12, 16 and 20. Find the smallest perfect square which is divisible by 12, 16 and 20, smallest, okay, perfect square which is divisible by 12, 16 and 20. And so what is it? This, now you can find a number which is divisible by these three, and you can find also the smallest number which is divisible by this. Okay, but then they are looking for the smallest perfect square which is divisible by this. Now what to do? First thing, let us find smallest number divisible by these three numbers. Okay, 12, 16 and 20 is the LCM of these numbers, isn't it? So if you find the LCM of 12, 16 and 20, okay, so it is 2 and a 6. We are doing it by prime factorization. 2, 8 and a 10, and it is a 2 and a 3 and a 4 and a 5 over 4 into 3. Okay, 4 into 3, 12, 12 4s are 48, 48 into 5, that is 840, 240. Okay, so 240 is my LCM. Now we have reached the smallest number which is divisible by these three things, but we haven't reached the smallest perfect square which is divisible by these. So what we'll do next is we are going to find a square root of 240. Okay, not square root, sorry, prime factorization. So 2, okay, why? Because we are trying to see which factors make 240. So 2, 120 and a 2 and a 60 and a 2 and a 30 and a 2 and a 15 and a 3 and a 5. Now see, this is what I want to show you all. There is two pairs of 2, but then the 3 and the 5 is not having a pair. Since the 3 and the 5 is not having a pair, it is this which is making it not a perfect square. In order to make 240 a perfect square, we have to multiply it with another 3 and another 5. Okay, so we have to multiply 240 with a further 15. 240 with a 15, if we multiply, okay, we can get the smallest perfect square. Okay, 3600. Okay, so 3600 is that number which is a perfect square also. It is the smallest such number also which is divisible by all these three. Now if you still have confusions, let me tell you, if 240 is divisible by these three numbers, if I write 2 into 2 into 2 into 2 into 3 into 5, this is also divisible because I have written down the factors by these three numbers, right? Because 240 was divisible. Now if I add one more 5 and one more 3, don't you think that still these three numbers are able to divide this individually, isn't it? So if once a number, like if I say the number 10 is divisible by 2 and 5. Okay, simple example, number 10 is divisible by 2 and 5. Okay, then if I multiply this 10 with a 2, now I get a 20. Don't you think this 20 is still divisible by 2 and 5? Yes. Okay, multiply it with anything, multiply it with a 5 and you get 50. 50 is still divisible by 2 and 5. So we had got a number 240 which is divisible by these three. We multiplied that number with a 15 and just to make it a perfect square, but remember it is still divisible by these three numbers. Okay, So I think we'll stop here today, and with that we come to the important types of questions of this chapter. Okay, so we shall be continuing with cube roots. In my next video I shall be uploading cube roots. Okay, so all the links will be provided, all the different parts of square roots will be provided in the description box. So keep watching, and if you have liked the video, do not forget to like, share and subscribe. Okay, keep watching and keep practicing. Till then, bye all of you.